Hello, so in today's video, we're going to look at what the meaning of ln is. So you may see in your calculator this ln button, or you may have seen before this ln function, this ln of x function before somewhere when you've done some reading. So what actually is this? So today's video is going to be about what that means. So it's actually quite simple if you've watched the last few videos on logarithms and exponentials. It's quite simple on what this actually is. So ln of x is just the same as the logarithm in base e of x, where e is this 2.7, this very important number that we looked at the other day. So ln of x is just simply the logarithm of base e of x. That's what it means. So ln of x is just the power that you need to raise e by, this number e, in order to obtain that input of x. That's what it is. So yeah, you just need to know that. So to go through this in a more explicit way, if e to the power of x equals b, then ln of b is equal to x. And the reason for that is because remember what we did yesterday. So we said that if a to the power of x is equal to b, then the definition of the logarithm is that the logarithm of base a with that base there of a is of this number b is the power that you need to raise a by in order to obtain b, which is x. So that was our definition. So what we've just done here is we just said, okay, let's say we've got a base number of e. Let's call this number 2.7, this e there. So I'm going to swap that with an e there. So that means that x is equal to log base e of b. So remember the definition of log, this ln is that ln is equal to log base e. So therefore what we can say is ln b is equal to x. And another point I'll just say as well that I was about to say on the tip of my tongue is that this ln is also called the natural logarithm. So ln is sometimes referred to as the natural logarithm. So natural logarithm. So that's why you've got the L next to the N there. That's where the N comes from. So natural logarithm. So yeah, I mean, the reason why we write ln instead of this log base e, I mean, you could write that if you want to, but it's just easier to write ln because this is probably the most important logarithm that you'll ever see in maths. Just in the same way that this e to the x is probably the most important exponential function that you'll use in the rest of your maths education. So ln is just used as shorthand for log base e rather than just writing out the extra letters there. Okay, so we now know that the log base e of x is the inverse function of e to the x. So why do we know that? Because of yesterday's video. So in yesterday's video 122 in my pure math series, we said that the log of base a is the inverse of a to the power of x. So what that means is the log of base e is the inverse function of e to the power of x. So in other words then, ln of x, because again, it's just easy to write ln of x rather than log base e. So ln of x is the inverse function. So it's the inverse function of e to the power of x. So that's kind of the key point that we've got to bear in mind. So, I mean, if we look at a sketch of the graph then, so we've got this exponential graph that I've already drawn then. So this exponential curve, y equals e to the power of x. So we know that the ln function is the reflection of that curve. So it's going to be the reflection. So this would be our ln curve here, this increasing y equals ln x curve. Again, it's always increasing because of the fact that your reflection, this e to the x inverse, is always increasing. So your inverse function will increase too. And we've got this this x-intercept of 1 because we've got a y-intercept with the inverse of 1 there. So that's how the graph works. And we can use it, therefore, to solve equations like this where we've got a base of e. So if we've got e to the power of x equals 20, how are we going to solve this equation? How are we going to calculate the x value? Well, what we can do is you can just use a log on both sides, the ln both sides, to get ln of e to the x equals ln of 20. And then remember that ln and the exponential function are inverses. So because they're inverses, we just get an x there. So x equals ln 20. You can then put that into your calculator. So if I do that on mine, ln 20, I get about 2.996 to 4 significant figures. So 2.996 to 4 significant figures. So that would be my solution there. So basically, if you do on your calculator, e to the power of, so again, you'll probably see the e button on your calculator. You'll probably have a button like, maybe a button like this on your calculator. So e to the power of, and then you're going to press this 2.996. Hopefully you should get about 20, and you will get about 20 for that there. So that's kind of how you can use these natural logarithms to solve these equations where you've got exponential, the e constant in your base, So the key point to remember really is that the logarithm, natural logarithm ln, is the inverse function of the exponential function e to the power of x.